Okay, so we got H and K, H left and right, K up and down. We're going to come back and we're going to talk about A and B in a second. We're going to go work with them first. Don't let me forget to come back because I totally will. Okay, so given this first equation, you can see where you've got an A, an H, and a K. What do we know H and K to as? Besides it going left and right and up and down, yesterday we figured out it was also what? X and Y for what? For the vertex. So therefore, based on this, what is our vertex? 4 and -6 because insiders lie. Outside is a good guy. So we're going to write over 4 and we're going to go down -6. Now, when we graph, we totally do it in a different order than when we describe the transformations. Describing them, you have to go in a specific order. Graphing, we kind of do a different thing. So the next thing I want to talk about is that 2, the A value. Is that on the inside or the outside? Outside. If it's on the outside, does it impact the X's or the Y's? So we're wondering, right? If it's inside with the X, it impacts the X's. If it's outside, it impacts the Y's. Okay? So if it impacts the Y's, is that going to be horizontal or vertical? Vertical. So we know the K moves it up and down, right? Because it's a plus or a minus. The 2 is multiplying it, though. So this is going to be one of those stretcher compressions. On an absolute value, it works a lot like a slope. So if it's 2, you literally can count up and over like so. Up 2 over 1, up 2 over 1, up 2 over 1. And then they all have buddy points, right? Because they reflect over the axis of symmetry. And I'm going to do one more. Why did I do so many points?
So you get the solution.
I want to get the perfect. I want to get the solutions and the y-intercept. Love it. So there's my absolute value. Now I want to talk about that A value with regard to every single function we'll do from here on out. If I had graphed the parent, it would have gone right through here, right? Like so. It's 1, 1, 1. So do you see how this point right here compared to this point right here, compared to this point right here, we got 1, 1, we got 2, 2, we got 3, 3. Do you see how all my values doubled? I took 1, multiplied it by 2, and I got 2 up, right? Multiplied by 2, I went 4 up. Multiplied by 2, I went 6. So that's what that 2 does. It doubled them. Is that a vertical stretch or a compression? Stretch by 2. Good. So that's what our A value does. It's either going to stretch or compress. Okay, so now we have to write about it. Here are your choices. I always do B, H, A, K. That's my order. Doesn't mean it's the only order, but there are certain things that have to happen. When you do just order of operations, don't you always multiply before you add and subtract? Yes. So therefore, we always have to take care of our multiplying before we add and subtract. This is the inside. This is the outside. So notice I took my B, which is a multiplier, and it comes before H. I took my A, which is a multiplier, and it came before K. Because H and K are both plus and minus stuff. Does that make sense? You could have done A, B, H, K. That would have been fine too. Because notice A and B are going to be the ones that multiply, while H and K are the ones that add and subtract. So you can pick that order, but just make sure that before you talk about anything left or right, you talk about if B multiplied something. There's not a lot of B's floating around. We usually just deal with A's. Okay? If you talk about K is always last. No matter what, K is always last. Okay? So if I'm going to describe this one, where am I going to start? So tell me what I'm going to say. There's no B value, correct? So what is H doing to my graph?
It's moving it.
So right 4. Then I'm going to work my way out. So I always start on the inside and I work my way out. Now I'm going to my multiplier, A. What did A do? Was it horizontal or vertical? It was a vertical. Was it a stretch or compression? By what value? Perfect. And then the last thing that happened is the K value. What did that do to my graph?
Move it down.
Good. Did the domain change?
No.
Totally not. We still got all real numbers. What about the range?
It's all numbers greater than -6.
Or equal to. So now I'm going to write it in interval notation. So what does that look like? Interval. Okay, but what's the rest of it? I need a -6 included to infinity? Okay. Notice that is right there in your vertex. Doesn't mean it's always going to be the first number. It could be the last number, right? If it's going down. Okay. Axis of symmetry. Notice part of your vertex. Min or max? So how low does it go? Notice vertex. Also in your range, right? Now it wants me to find the solutions. There are 2 solutions, so I'm going to do set builder notation for good practice. X such that X equals what? Love it. Awesome job. Because our solutions are where it crosses the x-axis, unless it gives us some other y value. We okay with that?
Yes.
Can you tell me what A does? If A is greater, it's a stretch or compression. If A is greater than 0,
It's a stretch.
oh, we haven't even done this. Never mind. That's if A is greater than 1. My bad. Hold on. We'll come back to that in a second. Let's leave that. Okay, here we go. Oh. Okay, so now that we've done that other one, we can say that if A is greater than 0, in other words, A is positive,
It's going to be bigger. So be
it'll be what, a vertical stretch? Well, no, that's not true. We just talked about that because 1/2 is there. This is where A, if A is greater than 0, A is less than 0, we're talking about being positive or negative. So this one would be, it'd be a positive graph. If we were talking about concavity, we'd be talking about it concave up. If A is less than 0, then it's going to be negative. It's going to reflect over the x-axis. What does B do to our graph? By the way, this needs to be vertical. What does B do? It's the horizontal stretch or compression. What if B is less than 0? What do you think happens? If A reflects it over the x-axis vertically, B is going to reflect it over the y. So if B is less than 0, it's going to reflect over the y. Okay, bees are a beast. But the catch is once we do it, one, I'll tell you a few things that can help you. Starting off, though, we're going to learn how to transform a table as well. And the reason is because some of y'all are going to find doing the tables easier. than just going straight to the graph. I've been doing it for a while, so I can just do the graph pretty quickly. Okay, I'm going to start off, I'm going to do the table. I'm going to show you a transform table. Then I'm going to show you a transform graph, and then we're going to confirm that the points on our table are on the graph. Okay, so if I'm going to do the table, the first thing I need to start with is the parent. So I got an x and a y, and this is just the parent of absolute value of x. I'm going to go from -2 all the way to 2. Everybody okay with that table? I don't need to explain any part of that. We got that? It's kind of old news. Okay, so now we're going to create our transform table. So the first thing I want to do is decide everything that's in the inside. Keep in mind, this should look like b parentheses x minus h. If the b is distributed, in other words, there's no parentheses, the b is right by the x, you have to factor it out. We don't have that yet. We'll get to that part later. Let's do one thing at a time. So ours is b parentheses x minus h. Therefore, the value inside actually is h. Okay? All that stuff's inside. So if it's all inside, that means it's going to impact what? The x's or the y's? If it's impacting the x's, is that horizontal or vertical? I will keep asking you this question over and over and over again, and then it sticks. Okay, so our b value is 2, but we know insiders are liars. So instead of multiplying our x's by 2, what do you think we'll multiply them by? I agree with a half. The negative will simply flip it over the y-axis. It's a whole other beast. So you're actually going to multiply it by the reciprocal. So I'm going to take x and I'm going to multiply it by 1/2. And then it says take the x and subtract 3. But insiders lie. So we're going to add 3. Okay, so we're going to go ahead and transform that half. Now, I don't want ugly numbers. So I'm going to focus on which of these points do you think I actually want? Yep. Totally. I don't want -1 times a half. Now I got fractions. Nope, don't need it. All I need is a few points and I'm home free. So now we're going to go back to -1. No, -2 times a half. What's -2 times a half? Plus 3. Do good math. Half times 0 plus 3. 2 times a half plus 3. Okay. So those are our transformed x values. Now we're going to go do the y. To do the y, we need everything on the outside. So let's see. All I got is that on the outside, correct? Everything outside of the absolute value is going to impact our y values. If it impacts our y values, is that horizontal or vertical? Vertical. So this says take your y values and do what to it? So it's just going to be -y. So I got this one right here, -2. I got 0, 0 is just 0. And I got this one right here, it's -2. So at this point, I could just graph that, but I'm not going to. I'm going to go graph it by way of transformation so that you can see that. And then we're going to check and see if our points are actually there. Okay, first thing we would do is look for our vertex. What is our vertex in this thing? Perfect. Notice there's no k value, right? So it's just 3, 0. Now I'm going to draw a sketch of the parent because I want you to see what I'm going to do to the parent. That 2 is going to take your parent function, right? And it's going to take, it's like this, right? Look at me. It's like this. And it's going to take all your x values and it's going to cut them in half.
Does a compression.
It does a compression, right? What just happened to my slope? Did it get steeper or flatter?
Steeper.
It did. So a horizontal compression is just like a vertical stretch. Do you see it? A vertical stretch means I grab the arrows and I pull them up. So here I am, and a horizontal compression is the same thing as me vertically stretching it. Okay. So I'm going to go to, once again, pretty values. Do you see how this one's right here? And how far away is it? 2. I'm going to cut it in half. This one right here, how far away is that? So I'm going to take that point right there, and I'm going to cut it in half. Do you see how it's getting skinnier? We have an axis of symmetry. So each one of those has a buddy point. Do you agree? Okay, I have taken care of my right 3. I've taken care of my horizontal compression by 2. Now I just need to flip it over the x-axis. So this point right here is going to be right here. This point right here is going to be right here. And then I'm going to plot the buddy points. Oh, sorry. So here's my question. If you were to look at the right side, can you tell me what the slope of that right line is? -2. What's the b value? 2, and then there's a negative on the outside. So it ended up still being basically the same as if it was -2 on the outside, right? Because if I do a horizontal compression by 1/2, that is the exact same thing as doing a vertical stretch by 2. We okay with that idea? Okay. So let's see. Now I want you to go look. Remember our table. Do you see the point 2, -2 on our graph? What do you mean no?
Yes.
Thank you. Do you see 3, 0?
Yes.
Do you see 4, -2? So you could pick which way you're more comfortable with, right? Some of you may feel a little overwhelmed at doing this graph right off the bat. You may get more and more comfortable with it, but right now, especially when you're dealing with B. Dealing with A, you'll get used to that one really fast. So that's your call. Okay, so now we have to describe it. So we're going to start on the inside. This time we have a B. We have to talk about that first. Is that vertical or horizontal? Horizontal. Is it a stretch or a compression? It's going to be by 1/2, so that needs to be a compression, right? Between 0 and 1, it's going to be a compression. Then we went, what did the 3 do? Right 3, good. And then the negative on the outside?
Reflected over the x-axis.
There you go, reflected over the x. Domain? So in none of these is the domain change. Range, be careful.
It's
0 to
Woo! Did you hear the be careful part? Start at the bottom. Always go bottom to top. Why? Because the number on the left will always be smaller, and the smaller y values are down below, and the bigger y values are up top. So domain, it's always left to right. Range, always left, bottom to top. Okay? Axis of symmetry. Notice, both of these values are sitting up there in our vertex. And then min or max?
max is 0.
Once again, sitting there in our vertex. And then finding the solutions. We have 1, so I'm just going to do a point.
3, 0.
We okay with that? Okay, let's try another one. This one's much better because it's just got an A value. You want to go back and do it now? Oh, yeah, we probably can, right? Okay, looking at this one, what's your vertex? Okay. So I got -3, 6. Now, this one is that A value is 1/2, which means we would take all of our Y's and we'd cut them in half. So let's see, if I sketched out the parent, it would look like that, correct? You see this value right here? You see how it's 2 up? I would cut that in half and it'd go right there. Notice what the slope is. 1/2. So when it comes to these, we can literally just kind of do the slope, can't we? And then they all have buddy points. Describe the transformation. Let's start on the inside. What did it do? Left 3. And then we got 1/2. What did that do? Horizontal or vertical? Vertical. Compression by 1/2. So if you saw compression by 2, would that make sense? No, one of those is wrong. Because if it's a 2, it's a stretch, right? Okay, and then the last thing, the 6? Up 6. Domain? Range?
6 included.
Good. Notice that 6 is sitting there in our vertex. Axis symmetry. Notice that's in our vertex. Min or max? How low?
6.
Once again, in our axis of symmetry. Solutions. So I'm going to put no solutions. No sol. We okay with that? So I find it really helpful to write equations of graph while graphing them simultaneously, because when you do that, sometimes it really helps you connect the two. So I provided a couple graphs. The first thing we're going to need, oh, and FYI, never use B. When you're writing the equations, it's always A, H, K. Okay? Just because it's easier. You can use a B, but that just makes them more complicated. So looking at this, first thing you want to do is label your vertex. Okay, I agree. So that means I got X what? -4 plus 5. Perfect. Now I just need my A value. So if I go find another point, what is the slope of that right side? -3. Boom. That's it. See if you can do the one on the right with your group. So I'm hearing it pretty much around the room. X, insiders lie, so +4, -7, and then you determined up 1/2 on the right side. Always double check that your A value matches your graph. If it's positive, then your graph should be going up. If it's negative, then your graph should be going down. Okay. The next thing you'll have is some practice solving. Once you're done with that, then you can get your homework, because we definitely need practice with this. By the way, this right here, these are the exact same thing. Agree or not? Yeah? It's totally the same thing. So you can rewrite it if you want, or you can do it the way it is. It's whatever you want to do. Okay? Remember, until the absolute value is by itself, you cannot break it out of jail. Also, pay close attention to your signs. Some of the biggest mistakes we make are with our signs. And anytime you multiply or divide by a negative for your inequalities, the sign has to flip. Okay? When you're done with that, let me know and you can get your homework. Questions for me?